Okay, adding and subtracting rationals follows the same rules as fractions. Seriously? When you add and subtract fractions, what do you need? Do you remember, Jagger? I just asked you a question. Okay, you need a common denominator. So 12 and 6, what's common to them? And do not say 6. In order to make common denominators, you have to make it bigger. So 12. So we're going to, because we don't want to divide by 2, because if we divide by 2, then we have to divide 5 by 2, right? And that's craziness. So we'll times this side by 2 over 2 and make the common denominator be 12. That's why you don't divide. 5 over 12 plus 2 over 12 is 7 over 12. So once you get that common denominator, you just rewrite the denominator and add or subtract the tops, right? The numerators. 8 and 3. What do you need? Try the next. What's the common denominator between 8 and 3? 24. Okay. So we'll times this one by 3 and 3. What you do at the bottom, you have to do the top. Why do we times by 3 over 3? Because 3 over 3 is just 1. You can multiply anything by 1 and it doesn't change it. So that's why you do it to the top and the bottom. Because some people think, well, I can just do it to the bottom. The reason why you do it to both is because this is technically like 3 divided by 3, right? When you're doing it to the top and the bottom. And 3 divided by 3 is just 1. And that doesn't change anything, right? If I multiply anything by 1. So that's why you do it to the top and the bottom. And then this one's 8 and 8. And so you get 15 over 24 minus 16 over 24, which is negative 1 over 24. Okay. So adding and subtracting rationals follows the same rule, but as we know, rationals involve trinomials and binomials and variables and all that fun stuff. So we have to factor each denominator first. So if necessary, when adding and subtracting rationals and solving, which is our next lesson after our major quiz, you have to factor the denominators if necessary. And then you state your non-permissible values, and then based on that, you'll get a common denominator. Okay? Then you add or subtract the numerators, just like we did with fractions. So first thing we're going to do, 2x plus 4, x squared minus 9, 7x minus 10, x squared minus 9. Okay, well, do you know how many of you will start factoring the denominator? Which you can, and you'll see that they're the same. But then you'll also factor the numerator. Do not do that. If you factor the numerators and you factor them out, you're going to have to put them back in and then collect like terms and add and subtract them. So the only thing, when you're simplifying and you're multiplying and you're dividing, then you do for sure factor the numerators and the denominators. But when you're adding and subtracting, you just factor the denominators, okay? Very important. Just factor the denominators. So if you're someone who thinks you're going to go right ahead and try and do GCF of the 2x plus 4 and pull a 2 out, right? Only factor in GCF the denominators with adding and subtracting. Okay? That's it. So right now we actually have a common denominator, don't we? But we can factor it out if we want, just so our NPVs are easier. So let's factor the bottom. We're going to get x plus 3, x minus 3, because it's a difference of squares, plus x plus 3, x minus 3. And then we just rewrite the tops. 2x plus 4 plus 7x minus 10. Do not take that 2 out on the top, okay? Don't do that. If you take the 2 out, when we go to put these back together, you're going to have to put the 2 back in so I can collect like terms. It's just going to be, you're going to do extra work for nothing, okay? So we only factor in GCF the denominators. So now because we have a common denominator or whatever, we have our denominators, we can state our non-permissible values. X can't equal plus or minus 3. If you're someone who's still finding non-permissible values hard, please come in. Now, we're not solving for any type of x or anything. We don't have something equaling something. There's no equal sign in here. There's only an equal sign between this expression and this expression saying that this expression is equal to this one. There's no trying to get it to equal x. And why I say that is because that's going to be the next lesson, and you'll get the two mixed up. This one doesn't have an equal sign in it. You're not solving. It doesn't even say solve. It says simplify. You're just trying to make it more simple. You're trying to take two rational expressions and put them together. That's our ultimate goal. That's what simplify means. Put it together and see what we get. Okay? So we have a common denominator. We can write them over that. X plus 3, x minus 3. And then we just write our whole numerator over it. 2x plus 4 plus 7x minus 10. And when you're adding 7x minus 10, you can just write it out without brackets because you're adding the 7x and you're adding the minus 10. It's not changing it. Subtraction will give us a little bit of an extra step. And what did we do? We just added the numerators when we did fractions, right? And then just rewrote our denominator, right? So that's all we're going to do. 2x plus 7x. Do you see now if I would have took the 2 out, I'd have 2 bracket x plus 2. So what would I have to do? Put it back in and get 2x plus 4 in order to do this. So don't factor GCF the numerators. So 2x plus 7x is 9x. 4 minus 10, negative 6. Over x plus 3, x minus 3. The very last step, if you can simplify anything more, then you can. So what could we do to the top now? Just because it's the very last step. We could take out a 3. And we would be left with 3x minus 2. The reason why we want to check this in the very last step is because we want it as simplified as it can go. And we want to see if there's anything in the numerator that matches anything in the denominator that could possibly cancel. And nothing can. So we're done. So ultimately, to add rationals, we need common denominators, right? Or to subtract rationals, same thing. So this next one is subtracting. Okay? We have AB, AB in our denominator. So we have common denominators already. So that's good. So if we have our common denominators and can't factor the denominators anymore, GCF, then we state our MPVs. Remember, these could be in separate brackets, like A and B by themselves like this. So technically, our non-permissible value would be A, comma B can't equal 0. What does that mean? That's just a nice way of writing them together and saying A can't equal 0, B can't equal 0. These are the exact same thing. Once we have common denominators, we can write them all over the one denominator and put the top all over the one denominator, like both tops, right? Both numerators. So we get AB on the bottom. And on top, we get 10A plus 5 minus 3A minus 2. Am I missing something? The answer to that is yes. What am I missing? What did I minus? Essentially in the end. I just minused the 3A. What do I need to minus? The 3A minus 2, right? This subtraction is subtracting everything after it. So I'm subtracting 3A, so I get negative 3A, and then I'm subtracting negative 2. So what am I actually getting? Plus 2. You have to subtract everything that comes after the subtraction sign. Basically, it changes all the signs behind it, right? You have to remember to do that. That is the common error with adding and subtracting. Everyone forgets to subtract everything that's after that subtraction sign, okay? Now we can collect like terms once we've subtracted properly. 10A minus 3A is 7A. 5 plus 2 is positive 7 over AB. Now that I have them together, I can say, okay, is there anything more I can simplify? You take a 7 out. And then I'm left with A plus 1 over AB. Okay? Now flip over. It's obviously not going to stay where I'm always going to give you common denominators. Okay, let's look at this one. X plus 1, and x plus 1. So the first thing I have to do is factor or GCF my denominators, right? Can I do that, or are they good? They're good, right? There's nothing more I can take out of them. Then I state my non-permissible values. So I have x plus 1, and x plus 1. So I state what x can't be. So x can't be 0, or -1, or -1. So just -1 once. We don't have to write it twice. So I factor my denominators. Didn't have to. They were good. State my non-permissible values. Done. Third step, I have to get common denominators or there's absolutely nothing I can do. So I have x and x plus 1, and the other one is x plus 1. So what can I do to the right side so that it looks like the left side? Multiply by x. And you have to do it to the top and the bottom. So you're going to get x minus 15 over x plus 1, plus x squared minus 4x over x plus 1. So it's not super difficult to get common denominators, right? You have to remember to distribute that numerator in. Now we have common denominators, so we write them all over the denominator. So on the denominator we have x plus 1. And then we have x minus 15 plus x squared minus 4x. I didn't need to change any signs because it's an addition, right? And now I just collect like terms. X squared, x minus 4x is negative 3x, minus 15 over x plus 1. Is there anything else I can do? Factor the top, right? We need to check. Sometimes you can't actually factor it. This one you can. It's what gives me negative 15 and adds give me negative 3. It's going to be, no, it doesn't work, does it? I think this was a 2, because then it would be 5 and 3. 15 and 1 doesn't work. 5 and 3 doesn't work. We're good. That's all it can do. You actually can't factor. If you could factor it, you do. If you can't, you don't. Why don't we go to quadratic formula? Because I don't want what x equals. I just want it factored. And the only way I can factor it is by factoring. And if I can't factor, then I can't get factors. So, yep, next lesson. Okay. This one, we have x minus 5 on the denominator. That one's as low as it can go, right? And then we have x squared minus 2x minus 15. So the first thing we want to do is factor that. X squared minus 2x minus 15. So what times what equals negative 15? What plus what equals negative 2? X minus 5 and x plus 3. So we get 6x. So it equals 6x over x minus 5. I put it in brackets. Minus 240 over x minus 5x plus 3. So first thing we do is factor the denominators if possible. Next thing we do, state non-permissible values. So what's my non-permissible values? X can't equal 5 or negative 3. Now I have to get a common denominator. What can I do to make them common? The same. Multiply the left side by x plus 3. So we're going to get 6x times x, which is 6x squared. 6x times 3, which is positive 18x, over x minus 5, x plus 3. Why wouldn't I FOIL the bottoms together? Ultimately, I'm trying to do what? Get the same common denominator and simplify. If I put them back together, I'm expanding it. And then at the very last step, I'm going to have to factor them back out, which would not be helpful. Minus 240 over x minus 5x plus 3. Now we can write over one denominator, x minus 5x plus 3. And we have 6x squared plus 18x minus 240. In this case, we only have one term after the minus sign, so we don't have to remember to put it to everything else because it really only is one term. Question is, I could take a 6 out. X squared plus 3x minus 40. Multiplies give me 40. Negative 40. Ooh, I can actually do, that's 8 and 5. Positive 8, negative 5. This can factor. So you're going to get 6x plus 8, x minus 5. So sometimes they can factor and sometimes they can't. And then x minus 5, x plus 3. And what can we do? So if you get down to this answer here, this one here, but the multiple choice answer isn't there, don't think I'm wrong. Think maybe I can reduce it more. Okay, I can take 6 out. Okay, I can factor it. Okay, then they cancel. Ah, the multiple choice answer is there. So don't always just think you're wrong. Okay? You try these two. You try those two. Okay, so both of these share an x minus 2 in common. So I don't have to do the x minus 2 again. But the one on the right has an x plus 2 and the one on the left doesn't. So I have to go x plus 2. And the one on the left has an x plus 6 and this one doesn't. Yep. So you're going to get 2x times x, 2x squared. 2x times 2, positive 4x. 2 times x, positive 2x. 2 times 2, plus 4. Over x plus 6, x minus 2, x plus 2. Minus x, it's not a difference of, this one was a difference of squares. You FOIL the tops, but you never do the bottoms. You have to distribute the tops just like we distributed into the brackets on the tops so that you can collect like terms after. You don't do the bottoms. If you don't distribute the top, how are you going to collect, you know what I mean? X squared plus 6x plus 1x plus 6. You guys need to stop talking. X plus 6, x minus 2, x plus 2. Now, we can write them all over the same denominator. X plus 6, x minus 2, x plus 2. And so you're going to get 2x squared plus 4x plus 2x plus 4 And what do you have to do after behind the subtraction sign? Change signs basically because you're subtracting them. So minus x squared minus 6x minus 1x minus 6. So on the bottom you have x plus 6, x minus 2, x plus 2. And then you collect like terms. So 2x squared minus x squared, x squared. 4x plus 2x minus 6x minus 1x. 4x plus 2x is 6x, minus 6x is 0, minus 1x is negative x. And then 4 minus 6 is negative 2. And then, yes, we are not done. We can factor the top. But multiply is going to be negative 2, now it's going to be negative 1. X minus 2x plus 1. These cancel, and I'm left with x plus 1 over x plus 6, x plus 2. For your homework, I am going to give you 8 questions only, not 8 questions with 4 parts. 8 questions only. You need to complete them. If I hear the, are you going to check them, as in, are you going to check them because that's the only way I'm going to do them, one more time from you, I'm going to be so unimpressed. That is the only reason why you asked, are you going to check them? That is the only reason why someone asked that question. Uh-huh. Yeah. It's like, if no one checks the homework, does it exist? Is that what you're thinking? Okay. So page 336, 4AB, 5, DE, 6, C and F, and 7, A and C, and for Sebastian, all, the entire page, and the other one, and the chapter review, just for you. And I forgot